Many products of radioactive decay are themselves radioactive. Eventually, a stable end product is reached. 3 naturally occurring series have been identified: uranium, actinium and thorium series. You'll note the end product of each of these is lead. And these can be represented graphically. Here's one such representation which you might pause and just investigate the axes. You will have noted for alpha decay the arrow represents a reduction of 2 in the atomic number and a reduction of 4 in the mass number. For beta decay the arrow indicates an increase of 1 in the atomic number and no change in the mass number. Check the diagram again. Sometimes it can be represented with the elements present. Press pause and check what's actually there. So let's see if we can write some nuclear equations for this decay series. Note in this graph the mass number is on the vertical axis and it changes by 4 units, which makes it convenient because that's the mass number change for alpha decay. And across the horizontal axis with atomic number, we've got some handy hints of the elements of those atomic numbers, and we'll use that as we write the equations. So let's start with this point up here, which is atomic number 92, which is uranium, and mass number 238. So we have uranium 238, and it decays to give us thorium 234. And just check that it is alpha decay. So there's a decrease on this side of 4 in the mass number, so there must be 4 in the particle that's ejected, of mass number. The atomic number of the mass of the particle ejected must be 2, and that makes that an alpha particle. And there's always some energy given off. That's the first step in the decay series. The next step brings us across to here, which is protactinium. So we start with thorium. And we end up with protactinium 234. And you'll notice there's no change in the mass number. So the particle that's ejected has no mass number and an atomic number of -1, because the sum on this side has to equal the total on the other side, and that is a beta particle, and of course some energy given off as well. Next step in the series, we start with protactinium 234, and we end up here, back at uranium, but it's uranium 234. No change in the mass number, and this particle that's ejected has to have a -1 for its atomic number, which of course makes it a beta particle. We can continue. The next step is from here to here. So we start with uranium 234, and I think by now you should see the pattern and what's happening. And we end up at thorium 90 atomic number, and 230. 230 the mass number, thorium with atomic number 90. So the particle that has to be emitted has to have a mass number of 4. There's 92 atomic number here, there has to be 92 atomic number total over here, so there must be 2 atomic number for the particle emitted, which makes it an alpha particle, plus some energy. Okay, so I think you get the pattern that's building up here. What I'll get you to do is pause the video in a moment and continue, see if you can finish off writing the equations for the decay series. It might be useful if you use this table where you can see what the products of each decay are. Or you could just simply use the alpha decay and figure out what the product should be. And follow the pattern down. So pause the video now, and when you've finished, check your answers and I'll work at the same time. So, how did you go? You might have to press pause to check all those, and hopefully I've paid enough attention to the detail. Check your answers, see if we agree, and if you've got any questions then make sure you ask in class the next time we meet.